Hello everyone. In this video, we will be discussing about worm gear design that is based on strength, dynamic wear loads and efficiency of the worm gears. So actually in the previous video, we couldn't able to cover up some of the important definitions. So before moving to this strength, dynamic and wear loads and efficiency, we'll just finish up that one quickly. Because we don't have any derivations for strength, dynamic or wear loads for this one. Just it's about the formulas discussion based on what assumption we are discussing. So first let us quickly finish up these things, that is the common terms which is used, so that it will be easy for us to understand the formulas still in a better way. So the following terms whatever I'll be discussing, which is having a direct connection with the worm gearing and which is very important from the subject point of view. So first one is nothing but axial pitch. This axial pitch is also known as a linear pitch of a worm, and it is the distance measured axially, that is parallel to the axis of worm, from a point on one thread to the corresponding point on the adjacent thread on the worm. And here it may be noted that the axial pitch PA of a worm is equal to the circular pitch PC of the mating worm gear when the shafts are at right angles. And moving to the second important terms, that is lead. It is the linear distance through which a point on a thread moves ahead in one revolution of the worm. For single start thread, lead is equal to the axial pitch. But for the multi-start thread, lead is equal to the product of axial pitch and number of starts. So mathematically, lead is equal to P into A into N. So PA is nothing but axial pitch and N is nothing but number of starts. And moving to the third important thing, that is a lead angle, which is basically the angle between the tangent to the thread helix on the pitch cylinder and the plane normal to the axis of the worm, and it is denoted by lambda. A little consideration will show that if one complete turn of a worm thread be imaginated to be unwound from the body of the worm, it will be form an inclined plane whose base is equal to the pitch circumference of the worm and altitude equal to the lead of the worm. So tan lambda, which is equal to lead of the arm divided by pitch circumference of the worm, that is m into n divided by dw, where m is nothing but module and dw is nothing but pitch circle diameter of the worm. So the lead angle may vary from 9 degree to 45 degree, and it has been shown by FA Halsey that a lead angle less than 9 degree results in rapid wear and the safe value of lambda is 12.5 degree. So better we need to remember this particular value, and even to avoid the wrong designs, we can go with the lead angle is 9 degree to 45 degree. And next one is tooth pressure angle. It is measured in a plane containing the axis of the worm and is equal to one half the thread profile angle, which is shown in the previous sketch, where the normal pitch is the distance measured along the normal to the threads between two corresponding points on two adjacent threads of a worm. So mathematically we can write down normal pitch Pn is equal to Pa into cos delta. So the term normal pitch is used for a worm having single start threads. In case of a worm having multiple start threads, then the term normal lead Ln is used such that Ln is equal to L into cos lambda. Next one is helix angle. It is the angle between the tangent to the thread helix on the pitch cylinder and the axis of the worm. It is denoted by alpha W. The worm helix angle is the complement of worm lead angle, that is alpha W plus lambda is equal to 90 degree. It may be noted that the helix angle on the worm is generally quite large and that on the worm gear is very small. Thus it is usual to specify the lead angle lambda on the worm and the helix angle lambda alpha G on the worm gear. These two angles are equal for a 90 degree shaft angle. The next one is velocity ratio. It is the ratio of the speed of the worm in RPM to the speed of the worm gear. So mathematically it is the worm speed divided by geared speed. So here L is nothing but lead of the worm and dg is nothing but pitch circle diameter of the worm gear, and we know the linear velocity of the worm, which is equal to L into Nw divided by 60. So N is nothing but number of starts of the worm. Now we can move to the actual topic of this video, that is strength of the worm gear. As always, worm wheel is the weaker member because it is basically a circular shape with on the circumference the wheels will be there. So as usual, worm wheel is the weaker member. So design should be based on the worm wheel only, not on the worm, that is a screw. So the strength of the worm wheel based on the Levy's equation from design data handbook, it is 23.567A. So since it is for the wheel, it is denoted as FT2, which is equal to allowable stress into face width into module into Levy's factor into the service factor. So where the y value is nothing but pi y2, where y2 is nothing but Levy's form factor for the worm wheel, and m is nothing but the normal module. N. So n stands for normal and m for module. Now for the face width from equation 23.564a and 23.564b, based on the like a d1 value, in case face width is less than or equal to 0.75 d1, then z1 is equal to 123, and if it is less than or equal to 0.67 d1, then z1 value equal to 4. And sigma O2, that is by default it is for the worm wheel. So allowable statistics of the worm wheel from the table we need to take it. And the velocity factor, it is 6 by 6 plus Vm. So we always consider the dynamic effect. So the FT2 tangential tooth load will be equal to 9550 into 1000 into power into service factor divided by N2 F2 as usual for the worm wheel. And Vm is nothing but the mean pitch line velocity of the worm wheel, which is pi d2 n2 by 60,000 meter per second. Then moving to the next one, that is dynamic load, endurance strength and wear load. So the dynamic load of the worm gear may be found by using the following relation, that is Fd is equal to 6 plus Vm by 6 into Ft. So in short I can write it as Ft by Cv, where Ft is the actual transmitted load and Cv is nothing but velocity factor. The endurance strength based on Levy's equation is F of f suffix minus 1, which is equal to for the worm wheel, that is allowable stress into face width into Levy's form factor into pi into the normal module. So according to Buckingham's equation, the approximate wear load Fw is equal to d2 into b into k. So here the d2 is equal to pitch circle diameter of the worm gear, and b is face width of worm gear, and k is nothing but load stress factor. From table we need to take it. And the last topic in this video, that is efficiency of the worm gearing. So the efficiency of the worm gearing may be defined as the ratio of output power to the input power. Efficiency when the worm drives the worm gear, so efficiency is equal to tan alpha. I mean we cannot call it as a tan alpha. It's a tan gamma cos alpha normal alpha into the cos of gamma minus mu sine gamma divided by cos alpha into sine gamma plus mu cos gamma. Here you should, to avoid the confusion, what is this alpha and gamma? So you can write it down where alpha n is nothing but normal pressure angle and gamma is nothing but lead angle. I think now we can able to remember it very easily. So it is the lead angle and this is the normal pressure angle. And this formula we can take it from the data handbook number 23.604H. And efficiency when the worm gear drives the worm, that is from 23.604 I. This is for H and this is for I. So when the efficiency, here the worm drives the worm gear, here the worm gear drives the worm. So the efficiency formula will be the cos of normal pressure angle into sine of lead angle minus mu of cos of mu into cos of lead angle divided by tan of lead angle into cos of normal pressure angle into cos of lead angle plus mu into sine of lead angle. And where mu is nothing but coefficient of friction, Vt is the rubbing velocity, that is pi d1 n divided by 60,000 into cos of lead angle, since it is for the worm wheel, and mu is equal to 0.0422 by Vt power 0.28. This is for the from the equation 23.570A. And the mu can be obtained from the table 23.97 also. And this is the thermal rating of a worm wearing, where the heat generated due to the work loss in friction must be dissipated in order to avoid overheating of the drive and lubricating oil, where formula is mu into F1 into Vt divided by 1000 kilowatts. So F1 is a normal force and Vt is a rubbing velocity. Formula is 23.603A, and heat dissipated formula is HCT into A into Tg minus Ta divided by 1000 into kilowatt. So that is 23.603 E. And A is the radiating area of housing, and that is 14.4 A, and small a is the center distance, and Tg is the temperature of gear, T is the ambience, and HCr is the coefficient of heat transfer. So we can continue the remaining informations in the next video. Thank you.